Hi everybody, welcome to Sunya and welcome to the high yielding series on environment. Okay, so now we will be doing the terminologies part 3. So far we have done terminologies part 1 and part 2, and I think combined we have done around 25 terms which are very important for the upcoming prelims 2023. Okay, so now I'll begin this series, and you know the format. We will be discussing all these terms briefly to the point, so that you are able to make best use of it. So the number one term in the news also has been Biofloc Technology or Biofloc farming. Okay, so here what this is, I'll just like for example, you can also be asked this term along with its farming, right? So I'll just briefly give you the context and then we'll discuss about it. Okay, so here this Biofloc farming was used successfully in Kerala and basically Kochi. Okay, and it is said to boost the aquaculture. Okay, so biofloc farming, number one. Now the term biofloc, some of you might not even know exactly what it means. Okay, so what is a biofloc? So basically in a biofloc you have an aggregate of bacteria, okay, let's say algae, along with the waste matter. Okay, so you have an aggregate of this, and the basic idea is that we will want to improve the quality of the waste. Okay, so it is in that sense a method for waste treatment. Okay, we had done terminologies related to waste treatment in our previous lectures as well. Okay, so this talks about waste treatment. Okay, and when we do the waste treatment, that also helps you. And here one is using fishes. So fishes, it is a high density fish farming. Now when the fishes, let's say even if you take a pond and in which you have fishes generate waste products which are rich in ammonia. Okay, now that ammonia has to be treated by different kind of bacterias. Okay, in our static classes also and in our prelims crash course we've done this in great detail, especially the nitrogen cycle. Okay, so you can also comment in the comment section after ammonification, that is the nitrogen which is converted into ammonia. Okay, after this there are two different processes. One is nitrification and other is denitrification. What are the bacteria present in each process? We've done that in great detail, so you can write down that in the comment section, right? So that is also one thing we need to know. Fine. So here basically there are three main objectives. One is to improve the water quality. Okay, second is for waste management, and third, which is a mixture of all of this, is better aquaculture. This is which is basically done using Biofloc technology. Okay, so if I have to now tell you that what is it, it is a high density fish farming. Okay, in a controlled environment, right, and where the wastage is used into useful nutrients. Fine. A similar thing also we see in aquaponics. Okay, aquaponics also utilizes similar thing, wherein the waste of these fishes, okay, is acted upon by nitrifying bacteria. Okay, and those nitrates are then later used on. Okay, so here just focus on what we've discussed so far. Improves the water quality, improves helps in waste management, and is overall boosting aquaculture. Fine, this is what I've explained it to you. The waste etc along with the bacteria, algae is going to be present, right, and these conversion of ammonia to nitrite, that's the first part, and nitrite becomes nitrate. This process is known as nitrification. Fine, that is there. And there is also one more term which is often used in this process. This process makes use of flocculation. Okay, so here what happens in flocculation, and again flocculation is a method of improving the water quality, which was also one of the objectives of the basic biofloc farming, right? So here if you can see, let's say these are different coagulants. Now when all of them combine and when they settle, so there is a bonding process which happens. Okay, so when these bind together, so this actually facilitates bonding, right? And then when these are settled particles, then they are easier to filter and separate. Otherwise, they are scattered overall. So flocculation is also seen in biofloc farming. So both these terms in general, what is biofloc technology and what is biofloc farming should be known to us. And secondly, what is the term flocculation, okay, which is basically a process in which a coagulant is added, all the scattered particles, they come closer, okay, this chemical bonding takes place, and then they're easier to filter and separate, okay. So here also, this is one thing you need to know. This is the basic part as to how the flocculation helps in filtration. Fine. Now the second term also, that is known as climate forcings, okay. So climate forcings, or let's say the radiative forcings, number one will tell you what is the overall impact of different, let's say, natural factors and also man-made or anthropogenic factors, whether they are overall heating the earth or whether they are cooling down the earth. Fine. If you see this image, you will see the portions in red are the ones which of course warm the earth. So this includes greenhouse gases, okay, carbon dioxide, methane, etc. We've covered that in great detail already, okay. And the ones which are having this blue component, these are the ones which cool down. Fine. So radiative forcings is the combined overall effect, right? So we'll also see which of the ones are positive radiative forcings and negative radiative forcings. Fine. So these forcings are basically, they either increase or decrease the effect in overall climate system. That is one thing we need to know. Second thing, these are positive climate forcings, okay, the greenhouse gases. If these are positive, it simply means it is going to increase the temperature. Whereas the things related to aerosols are negative climate forcings, okay, and these actually decrease, okay, or at least cool down the earth. They decrease the temperature, they cool down. One more thing you need to know here, with aerosols there is also a term known as albedo. Albedo simply means the reflectivity, okay. Again, in one of the other terms we'll also see ice, and specifically zombie ice. So here basically when we talk of snow, ice, clouds, etc., everything has a reflectivity with it, okay. So let's say the sunlight falls and some of the part is reflected by it, right? So this aerosol actually helps to cool down. Fine. So this term also, sometimes you may not even guess. You might think that positive forcings cool down. No, positive forcings warm the planet, negative forcings cool down the planet. So that is one thing we need to know. And if even this graph is this thing, and again a related concept here is the concept of earth budget, which you read in geography, okay. Incoming solar radiation, outgoing solar radiation, entirety of that, and then the greenhouse effect, okay. So overall, this is what will actually help you understand climate forcings in more detail, okay. Now moving forward, now this term is very, very important for the exam. The context is simple. In COP27, okay, in COP27, loss and damage fund has been created for the first time. Loss and damage fund, which is why in general climate finance is important for you, okay. So I'll just tell you few funds, you should read about it. In fact, if you already know, please write down them in the comment section. For example, read about Global Environment Facility, read more about Green Climate Fund, also read about Adaptation Fund, okay, because if you see articles in the last 3 odd months, just before and after COP27, everything is about climate finance, okay. And the reason is simple, it spoke about a loss and damage fund. Now two things: one, what is the concept of loss and damage, when was it spoken about, and then loss and damage fund, of course, created under UNFCCC in COP27. This happened in Sharm el Sheikh, okay, in Egypt. So that is one thing. Now simply put, loss and damage, let's say because of developed countries, a lot of emissions happened, and the consequences of that emissions have led to slow onset events and extreme onset events. Okay, because in climate change we know there are some slow events and then there are very fast or extreme events. Now there are in many cases very harmful impacts because of that, and there are loss and damages which the countries have to face. Imagine the plight of small island developing states. Okay, so let's say if the sea level will rise, these island states are a threat of getting submerged. Okay, so that basically includes loss and damage. Okay, I've also included in the slides the definition which is given by UNFCCC. UNFCCC basically says loss and damage includes the harms resulting from sudden onset events, okay, as well as slow onset events. Okay, so this is one. So for example, slow onset events can be a sea level rise. Okay, the ice sheet etc. is melting and it takes some time, okay, for the sea level to rise, but because of that livelihoods, okay, even the territories will be hampered. Now it says it will lead to migration and displacement. With that, there is another term that you need to know, that is climate refugees. The people who have been forced to move away because of climate change and its impacts. Okay, so there is a loss of lives and property. Okay, heat waves, water scarcity, overall agriculturally, economically, socially, there have been a lot of impacts because of this. So this is what is loss and damage. Now second, when was this concept introduced? So here you need to remember this was introduced in COP 19, okay, in Warsaw. Now can you mention this in the comment section? Where is Warsaw? Okay, in which part of the world, where is Warsaw? So this happened of course before the Paris climate deal in 2013. So for the first time the concept of loss and damage came in COP 19. Okay, COP is the conference of parties in Warsaw, right, in 2013, and the loss and damage fund was created, okay, in 2022 in the COP 27. So please make sure you understand both of them. The concept of loss and damage, there is a very high chance of this topic getting asked because of its relevance. Okay, so that is one. This is loss and damage. Moving on, we now talk about the fourth term. This is negative emission technologies. So number one, negative emission technologies. Other term, carbon sequestration. Okay, then carbon capture and storage. All these terms you often hear about. Okay, so I'll just quickly tell you what these are. Negative emission technologies are simply the technologies through which excess CO2 can be captured, okay, or it can be sequestered. Sequestered simply means to be stored, okay, or captured. Fine. So negative emission technologies, okay, will be, for example, coastal or blue carbon. Okay, blue carbon was already asked by UPSC. The oceanic and the coastal ecosystems which are able to sequester the carbon, that is known as blue carbon. Okay, so that is one. Second, if there is this accelerated chemical weathering of rocks, okay, so even then the carbon can be sequestered. Okay, there are different terms related to it, that is known as, for example, mineral carbonization. Okay, then there is this hydrodynamic solubility trapping, etc. Okay, which talks about or storing or capturing the carbon dioxide, CO2. Okay, another project similar, by the way, that does not happen on the land but in deep sea. What happens? You capture the carbon and you store it in underground coal seams, okay, or in different type of rocks. Okay, so even that can be done. Direct, you can capture the CO2, that is there. Okay, now if you see this image, there is also this basalt rock, and in the basalt rock carbon dioxide can be injected. Okay, this is right now being done in a project known as CarbFix project. Okay, CO2 being injected into basaltic rocks. Okay, that is also there. Then afforestation, always this is going to be happen. Even with the biomass energy, you are able to sequester and store carbon. That is also there. Okay. Afforestation, reforestation, you can easily understand. Through the process of photosynthesis, excess CO2 is captured. Okay, this is the natural method. These are geological interventions. All right, right, and even in the soil carbon, etc., through biochar, all these things can be helped to capture excess CO2. And the more CO2 you capture, the better it is. Okay, the lesser will be the greenhouse effect. Fine. So these are negative emission technologies. We've also understood what is meant by carbon sequestration, right? And UPSC has asked these kind of technologies many a times. Okay, so these terms should also be known to you. Then one more term in the news was marine heat waves. Okay, so we generally talk about heat waves on the land. Okay, so these are marine heat waves. How do you define them? Marine heat waves, basically when the temperature here of these heat waves is greater than the average temperature for 5 consecutive days or more. So the limit is basically 5 consecutive days. Okay, the increased temperature for 5 consecutive days leads to marine heat waves. Now you can imagine what kind of impact this would have. Okay, now this also is linked to climate change and global warming. Now if the temperature increases, think of impacts on different levels. Think of the impact on biodiversity. Okay, so biodiversity will decline. Now coral reefs will also in some sense be bleached. Okay, they'll die off. Okay, other phytoplanktons, they will also start to die. So a lot of biodiversity loss will happen, definitely. Additionally, deoxygenation will also happen. We discussed in the previous lectures what is hypoxia, dead zones, etc. So even this will happen. Increased warming will again lead to tropical cyclones, hurricanes, etc. And all these factors combined will also lead to economic loss. So our question can be, number one, what are heat waves? So for that, remember the increase in temperature for 5 consecutive days, right? Second, and by the way, the marine heat waves, one more thing, where will they be found? So just remember, they will be found everywhere in all the portions. Okay, both in the surface and in deeper portions of the oceanic ecosystem. In all the different latitudes you will find them. So it be equator, poles, you can find marine heat waves everywhere. Okay, so it is not restricted to any single particular area. That is one. Okay, now linked with this, there was also something in the news which is sponge bleaching. Okay, so this basically happened in New Zealand. So New Zealand has a lot of these sponges. Fine. So the loss and decay of these sponges was spoken about as a consequence of increasing marine heat waves, which is why I also covered marine heat waves earlier. Okay, so initially what it was seen that marine sponges, they were thought to be very resilient, okay, to the ocean warming. But now what we have seen that a lot of them, basically if you see the color also, the color also has changed. Okay, so color has changed and this bleaching has occurred. Again, these the marine sponges are important because they have a lot of biodiversity. Okay, secondly, they help in again filtering the water. Okay, they have a lot of ecosystem services, just like you might have read about wetlands, etc. They also provide, first of all, they help in filtration, they have a lot of biodiversity, they provide provisioning services. Okay, so these sponges are very important because, right, and the death of this is happening because of increased marine heat waves. In which area we have seen that? In New Zealand, around 70% of these sponges have been bleached. We've already seen there is a term known as coral bleaching. Okay, so now I have one small homework for you. Look out for the difference between a sponge and a coral. We read about coral bleaching. Now I'm telling you sponge bleaching. Now I want you to be more curious. Okay, and have a look what is the difference between sponge and corals. We will see that in the upcoming lectures as well. Okay. Then another term is zombie ice. Okay. Now if you see, zombie ice was in the news. Why? Because the Greenland ice sheet was melting, and this was attributed to this zombie ice. Now whenever we think of these different ice sheets, etc., think of IPCC's tipping points. Okay, IPCC has highlighted a list of tipping points, the regions in the world which are very vulnerable to climate change, and after a point the changes in this will be irreversible. Okay, so here also you have the Greenland ice sheet, etc. So these ice sheets are melting, and as a consequence the sea level is increasing. There is a rise in the sea level. That is also one thing we need to know. Okay, now second thing here is the issue related to the zombie ice. Fine. So let's say you have this ice sheet, and on the ice sheet, okay, so here what is happening, this is the one which is getting melted. Okay, and it does not have the fresh snow coming on top of it. Fine. So basically what is basically happening in the region, that on the ice sheet, okay, you have this zombie ice, and this zombie ice is leading to the extra melting of the ice sheet. Okay, so this is a process, or at least this was in the news, so we also need to know about this. Okay, this zombie ice, it is also known by another name known as doomed ice. Okay, so if you get this term zombie ice or doomed ice, both of them mean the same thing. Okay, secondly, I told you it is not accumulating fresh snow, not accumulating fresh snow. Fine. So these two things you need to know here. Okay, and this is melting, and because of this there is going to be an increase in the sea level. Now I've spoken about a body known as IPCC, Intergovernment Panel on Climate Change. Again, please tell me in the comment sections, when was this formed and by which bodies it was formed. Okay, I'll tell you, it releases a assessment report. Recent is the 6th assessment report, which is the most famous one. It has a lot of predictions and a lot of fact-based analysis, okay, on CO2, on sea level rise, etc., etc. So here it is also basically speaking about all these things. So zombie ice or doomed ice is melting, leading to this sea level rise. That is also should be known to you, so don't get confused if you see terms like zombie ice. Now another term is Arctic amplification, right? So number one, what is amplification? We've already done things like bioamplification, biomagnification, bioaccumulation, bioconcentration. Fine. And why is the term related only to Arctic? Okay, now one thing one already knows, that year on year Arctics has seen the overall temperatures to rise. Okay, so that is the first thing. Polar amplification is basically what is happening, that overall the earth is warming, but it is warming more, okay, near the North Pole and South Pole, and basically there is a higher temperature difference in the North Pole and the South Pole. This is leading to a lot of this warming, number one. And because the land based surface is more in the north part, so one is seeing more of these changes, or more sharp changes in the northern hemisphere, because in southern hemisphere one has more water bodies, and for water we already know the specific heat for water is higher. It takes long time to heat the water and long time to cool the water down, right? So here one needs to understand what is Arctic amplification. Okay, so basically the higher rise in temperature, especially seen in the Arctics. It is seen in the poles, but it is more predominant in the Arctic pole. Okay, so this term is known as Arctic amplification. Now of course, if Arctic amplification is happening, what will be the consequence of it? Okay, the consequence will be, of course, the ice sheets which are present because of the increasing temperature, the ice sheets will definitely melt. Okay, and the biodiversity loss also can happen. Okay, think about the polar animals, and these, For example, think about penguins, think about polar bears, etc. If the temperature is rising, they would also feel a lot of difference, and they will also be susceptible to a lot of these changes. Okay, so even that is one thing we need to understand here about this part, right? So the life of species, etc. will be at threat. That is one thing we need to know. This is the part. So if you see the image, redder portions or more red portions are seen specifically in the Arctic part or in the polar regions, right? While overall every portion is red, but this part is more red. This is the concept of Arctic amplification. Okay. Now one more term in the news, see, is Karakoram anomaly. Okay. Karakoram. So number one, based on your basic geography, you should know what is the Karakoram regions. Where are the Karakoram mountains? Okay. So that is number one. Second thing is this term anomaly. Anomaly means an exception, an outlier, or something which does not follow the rule. Okay. So everywhere, because of climate change, we have been speaking that because of climate change or because of increasing temperatures, the glaciers are melting everywhere. We've seen that, right? Now what is happening in the Karakoram region is basically that the glaciers are not melting, or in many cases they are intact. Okay, so this is the anomaly. So number one, what is the anomaly? And then what is the scientist's explanation for that anomaly? We'll see both these things, because the explanation part of it was also published in PIB, okay, few months back. So I'll see both these things. So what is Karakoram anomaly? Stability, or in fact the growth of glaciers. Okay, overall we're seeing the decline of glaciers, right? So here it is the opposite. So anomalous growth of glaciers in the central Karakoram region, that is one, because everywhere you are seeing a retreat of glaciers. This is why this is termed as a anomaly. Okay, so this Karakoram anomaly or the Hindu Kush region. Okay, so do this for both from environment and also from geographical perspective. Okay, even this ranges, etc. can be asked from you where this anomaly is exactly melting. So we know what is the anomaly. Now we'll see, for example, this was also published in PIB, that what is scientists' explanation for this. So basically the scientists have highlighted that the Himalayan glaciers which are resisting global warming, or because of this Karakoram anomaly. Why? Because they say due to the recent revival of western disturbances. Okay, so scientists basically have attributed it to this. So directly if you get a statement that it is because of the recent revival, so yes, this has been accepted by the scientists. So number one, now I have two more questions, because western disturbances, you read this in geography. So what is the outcome of western disturbances in India? Okay, any of the important or pronounced outcomes, you can just type that down in the comment section. Let's see what you come up with. Okay, and that will also help you revise the concept of western disturbance. Okay, so both these things, what is it, Karakoram anomaly, and why is this happening? So this is basically why is this trend not followed? Because of the revival of western disturbance. Okay, now one more thing very important here is carbon border adjustment mechanism, CBAM. Okay, so number one, this was proposed by EU. EU is European Union. Okay, and EU has been very prominent in climate change. It also spoke about a fit by 55. Okay, fit by 55 is simply reduction in greenhouse gases by 55% year 2030. Okay, EU, of course, you might have read in this in polity as well, spoke about GDPR, General Data Protection Rules. EU also came up with Global Climate Change Alliance, etc. So these are some things you need to know. But now let us focus on CBAM, okay, because this is very important. Now, two things you need to know. Number one, what is this and what was India's stand? So what is this? Let's say this is EU, or let's say this is in EU, you have, let's say, France. France is importing a product from another company. Okay, now if France feels that, let's say, a product from India is having an old technology, and because of that carbon emissions in this product is high, okay, so it can impose a tax on it. Okay, so this is known as carbon border adjustment mechanism, is also known as words first carbon border tax. Okay, this is a carbon border tax. So one might assume that, let's say if a product comes in, okay, so you will, if the product has a lot of emissions, the country can put a tax on it. So let's say it was for 100 rupees, the tax was 20, so now it is 120. So it is in a way penalizing the older companies or the companies which do not have good modern technologies. So as an idea you might think, okay, it's a good idea, okay, because it is an environmentally sensitive idea, right? So here these are EU producers. If it meets the standards, well and good. If it does not meet the standard of the carbon emissions, they can impose a tax on it. Now till here it is fine, but we need to know what is India's stand. India has opposed CBAM at the COP27. India did not support it. So I'm saying India and I'm putting a cross mark. India has opposed the idea of CBAM. Okay, according to India, see, why has India opposed this also you need to know. Okay, and with this we'll also see a term known as carbon leakage. India has simply said that, first of all, EU is just singling out a gas which is carbon. Second, India said that we are already following our pledges under the Paris Agreement. Third, they've said this is just a ploy of the developed world to again just make a difference with the developing world, and again one more method to stop our goods from entering their markets. So according to India, the developing countries have not developed because of actions of the let's say developed countries. Okay, so they are the ones which they need money. Okay, they need capital, they need technology. So if France or EU basically should have helped them to modernize their factories, put in money, so they're not doing that, and on top of that they're saying I will also not allow your products to come in. Okay, so this is basically the stand of the developing world. They say that this is a discriminatory practice. So India has opposed this one. Second, India is saying that this will lead to carbon leakage, which means emissions of carbon will happen. But let's say you're not taking a product from me, and you will take it up from some other place. Okay, we've seen things like tax havens. Okay, so basically, let's say you're not taking a product from one country, but let's say they are taking it from some other country. So the emissions from carbon will always happen. Okay, so India has not like supported the idea, India has opposed it. So two things again summarizing. Number one, CBAM is by EU. Okay, India has opposed this at the COP27. Okay, so this thing you need to understand. This is words first carbon tax. Now again if you're talking of COP27, India spoke about a long-term low carbon development strategy. This is what LTLED is. Okay, this is spoken about in COP27. In COP26, India spoke about mission life. Life is what? Lifestyle for environment. Okay, so this is something you need to know. Of course, in COP26, India also spoke about Panchamitra. Okay, Panchamrit, in that there are 5 pledges. Again, those of you who are watching the lecture, you can also comment that down. That will also help you remember that. The 5 pledges, all of you should remember it. Definitely useful for prelims, mains and interview, all the stages. Okay. Now this is low carbon development strategy. Secondly, India has also spoken about deep decarbonization. Okay, so these two terms, deep decarbonization and long-term low carbon development strategy. Now this talks about integrated, efficient and an inclusive system. Okay, better adaptation in designs, transport, fuels, mobility. Okay, and overall it talks about developing a low carbon economy as well. So not just one single sector, but multiple sectors which you can think of an economy is this. So one question can also be asked, for example, which or what are the objectives of this, or how can India achieve it, and in that maybe they can give you 3 or 4 good like terms which actually promote low carbon economy. So you have to be alert in such questions. Okay, and also mission life and Panchamrit also is something you need to know. Okay, and then moving on to just the last terms here. One is sinkholes. Sinkholes, if you can see, these are the depressions, okay, which are caused. Now these depressions can be caused because of two things, both. Sinkholes can be caused because of natural factors. These can also be caused because of man-made factors. Okay, so these depressions, sinkholes, etc. were also in the news. Okay, usually you'll find them in karst terrains, etc. Right? So here what will happen? Let's say there is the abrasive or the erosive effect of water, specifically in the case of groundwater. All right. So because of that, this surface of the rock or below the rock is the one which is getting dissolved or degraded, which forms this depression known as a sinkhole. Usually this was mainly because of natural causes, but now because of a lot of man-made reasons, a lot of these sinkholes also have been seen. Okay, so terms like this you can definitely find in Samadhan, the current affairs magazine. Okay, I've already shown that to you in all these videos. If you want to again solidify your preparation, you can make use of this. So these are these depressions, okay, sinkholes, okay, formed due to natural or human activity. We have already seen that. Now this is in the news because in China's Zhuang Autonomous Province this was already seen. Okay, so these sinkholes were seen because of, it can be formed because of these two both processes. Okay, so this is something which you can at least have an idea about. These are cave-like structures, okay, which are found underground because of both natural and man-made factors. Now the last term is Keeling Curve. In environment and in general in climate change, carbon dioxide is something which we read about very often. So Keeling Curve is basically telling us the concentration of carbon. It is measured in parts per million. Okay, so year wise there is a distribution, and everybody now would be aware that carbon dioxide concentrations are increasing. So this graph is also rising up, increasing. Okay, so this term has now crossed, CO2 levels have crossed 410 ppm. That is one thing we need to know. Fine. So Keeling Curve is basically just telling us the amount of carbon dioxide that is present, and that amount is increasing. Fine, demonstrated by the Keeling Curve. Okay, additionally what we also need to know, that there is a Mauna Loa observatory in Hawaii which talks about this particular thing. So Mauna Loa observatory in Hawaii is measuring all these things, and the curve which is used to monitor is known as Keeling Curve. Okay, this is about carbon dioxide emissions. All right, so this brings us to the end of this terminologies lecture. I think I'll just quickly go ahead and tell you what all terms we have seen so far. We started with Biofloc Technology, we saw flocculation, we saw climate forcings, we saw the concept of loss and damage, negative emission technologies, carbon sequestration, marine heat waves, sponge bleaching, zombie ice, Arctic amplification, Karakoram anomaly, okay, carbon border adjustment mechanism, carbon leakage, this LT LEDs, sinkholes, and last was Keeling Curve, right? So I think in all these lectures combined, we've seen almost close to, in these 3 lectures, 40 terms. Okay, terms based question are usually asked, so you can just make a small list 1 to 40 all the terms and your 1-line definition. Okay, so this ends the lectures on terminologies. I'll now be coming back and meeting you again in other high yielding topics. Additionally, if there are some topics in an environment which you want me to cover, you can just write down in the comment section. We are reading all your comments. So if you want any specific topic, any theme which you want to be covered, that also can be taken up in the high yielding topics. Okay, so till then, please keep revising. I'll meet you very soon with other set of high yielding topics. Thank you.